To be honest, you probably know the advice by now. Sturdy boots, a sun hat, some durable clothes, and don't believe everything you see in the movies, especially the reboot. Welcome to the Backpacker's Guide to Prehistory. Hello and welcome to the Backpacker's Guide to Prehistory, the podcast that provides top travel tips for time travellers. I'm your tour guide, David Mountain. For this episode, I've set my time machine for the Jurassic, the only geological period with bona fide movie star status. And it's easy to see why. Lasting from 201 to 145 million years ago, the Jurassic marks the midpoint of the Mesozoic and a golden age for those prehistoric superstars, the dinosaurs. But even if you're looking for something off the beaten track, the Jurassic still has lots to offer, from hikes through incredible forested landscapes to prehistoric birdwatching. It's definitely not the driest period in prehistory though. I had been hoping to end this season with a safari across Jurassic North America, where I'm currently camped. But it looks like the weather might force me to stay in my tent for the duration of the episode. On the bright side, I suppose, it does give me a little more time to plan my trip. And, as luck would have it, I've still got a decent internet connection back home to the Holocene. So, to help me navigate the Jurassic world, I'll be talking to two experts. Dr. Evelyn Costacha, Curator of Paleobotany at the South Tyrol Museum of Nature.
Hello.
And Dr. Elsa Pancharoli, a paleontologist at the Oxford University Museum of Natural History.
Hi.
Evelyn, first of all, is it going to rain like this a lot in the Jurassic?
Well, it is definitely more common than in other periods of time, that's for sure. But it depends a little bit on where you're going. So if you're going on the coastal area in the eastern part of the Pangaea, then yeah, of course, rainy, stormy weather is just normal. If you go more to the western or the central part of the Pangaea, then yeah, well, you could also have some desert climate there. So they're not always the same, you know.
Okay. So you've got to plan ahead.
Yeah, you have to plan ahead where you're going.
And to stick with practical matters, what should I pack? What clothes should I bring? Obviously a raincoat, but anything else?
Well, very light clothes. Consider that it's much warmer than nowadays, so we are 5 to 10 degrees warmer than nowadays, depending, again, when you're going or where you're going, so it depends on that. I would say, like in the very hot summer, if you go to the tropics nowadays, that would be fine. Sun cream, light clothes, nothing against mosquitoes, not so much, because they're not there yet, at least not as much as you can find nowadays, but yeah, I would definitely suggest just light things.
So, I've got a general gist of the world I'm travelling to now, but to talk a bit more about the plants in this world, when I set out, what habitats, what landscapes am I going to be exploring? Are we talking jungles, open woodlands, open spaces, or something different altogether?
Well, differently from what we are known for movies, which are just fiction and not like our travel, which is real, we of course have much more plant than which are normally on the pictures or in the movies, as said. Because of course in the movies and in the pictures they want to show up, especially with the dinosaurs, so they delete big parts of the beautiful plants that would have been there. But now, if you travel there, you will see that there are much more plants. There are open forests, there are quite closed forests as well, so we cannot really consider it a rainforest like nowadays, but it's going close there in some areas. As I said, in the tropical parts, in the eastern tropical parts of Pangaea, we would really find lush vegetation, so we really would find closed forests. Now, if we go more into the hinterland area of the Pangaea, so in the center, then of course it would be a little bit more sparse with the vegetation, and of course it would be less wet there, and so we would have more plants which are more a little bit adapted also to drier environments. But still, you would have, let's say, more green than you normally see it in fiction.
So let's talk about these plants. What are the types of plants that I am most likely to see when I'm out in the Jurassic? What are the trees? What's the undergrowth? What am I going to encounter?
The main trees, or the big trees, let's say, mostly conifers. And we have to imagine the conifers of some types that we can have even today. So, for example, Araucarias. Conifers were there already. We have a lot of different conifer types that we can find them, and they're really big trees. Then also on the big tree side, there can be some ginkgos already, and some seed ferns, which is a group of plants that nowadays doesn't exist anymore. And if we look into the understory or in the little bit lower vegetation, then what we would come up with are cycads, of course, which are up to 1 meter or something like that. And then the small plants, of course, are there. There are a lot of ferns, a lot of modern ferns, actually. A lot of the families we can see today in the botanical gardens actually have their ancestors there. So we could visit their grandfathers or grandmothers or whatever. And what else? We would have mosses, of course, because it's humid. So they would love that climate. We would have some horsetails, small ones, like nowadays. And also lycophytes, some small ones. So it would have been quite a complex ecosystem.
That's really interesting, because when you go to the Mesozoic, you prepare yourself to think it's going to be an alien world. But a lot of these plants we know from today, I can picture them. I can almost imagine what they might look like together.
Absolutely. So most of the ancestors of the modern plants are already there. The only thing that changes in relation to nowadays flora is the fact that we have almost no angiosperms, so all the flowering plants that we use today, especially in the lower and middle latitudes, that are not there. Or let's say there are some possibilities, there are small ones probably going around already, but nothing that you would really recognize at the first place. So the vegetation is rather different from what we see nowadays. But just because the percentage, so the composition of the flora itself is different. So we could, if we travel to the mountains, or if we travel to higher latitudes nowadays, where we have these conifer forests, that's something like more similar to what it has been or what it is in the Jurassic actually. So it's more the composition that changed, but the type of plants are there. And especially the understory does not change, because a lot of the taxa we have there, even as a genus level, we already have them there. So it's quite funny because it's quite close to what we are used today. Just not, let's say, the predominant angiosperms.
Something that any visitor to the Jurassic will quickly notice is that these plants are being eaten by huge herds of sauropods and other herbivorous dinosaurs. So did plants evolve any defences against these herbivores?
Well, it's always an interaction. It's always a giving and taking because, of course, herbivorous dinosaurs are very important for the dispersal of seeds, for example, for the plants, like nowadays as well. There are some defenses, but most of the defenses that we can observe are more against insects. So, for example, they create some trichomes, or small hairs on the surface, which gives the insects troubles to get on the surface or get its cuticle. So the great defenses against insects. Of course, trichomes or the hairs are not nice for the sauropods as well, because who wants to eat something that is hairy? But let's say they get very lineose, so they get much more hard tissue into the cones or whatever. They close the cones, for example, because of course, if they close the cones, the dinosaurs are not that easy in reaching the seeds anymore. So they have to find a way to get out the seeds, which of course makes the ginkgophytes great for the dinosaurs. So let's say we are very happy that the dinosaurs didn't extinguish the ginkgophytes with all the eatings of the seeds and their fruits. You know that it's fleshy, its seed is high in nutrition. Just think about it. If you're a dinosaur and you just have to eat ferns, that are nice, but it's like salad for us. So after a few hours, you're hungry again. There's nothing there substantial. You need more. And of course, the idea is that some of them could have stones in their stomach. So in order to treat the lineous parts, in order to get them more soft and can get the energy out of them, or having them longer in the stomach, meaning that the enzymes could get more energy out of it.
The tropical and subtropical conditions found throughout much of the Jurassic world mean that large stretches of the continents are covered in warm, tropical seas, and these are teeming with amazing life forms. Some of the Jurassic's big boppers include the long-necked plesiosaurs, the short-necked pliosaurs, and the dolphin-like ichthyosaurs. Other animals to look out for include sharks, marine crocodiles, some of which could grow up to 10 metres long, and the Jurassic behemoth Leadsichthys, a 20-ton fish that filtered plankton out of the water, much like modern baleen whales do today. You will probably have noticed that many of these creatures are very capable killers, and while they're unlikely to deliberately hunt down a human, swimmers are strongly encouraged not to venture too far out to sea. You can bring a shark cage with you, but to be honest it's a hassle to strap to most commercially available time machines. Besides, a land-lubbing Jurassic beach holiday is still great fun. You hardly need to get your toes wet to find ammonites. These iconic cephalopods, with their coiled shells, are some of the most well-known animals from all prehistory. But if we're talking about famous fossil fauna, we have to talk about the dinosaurs. And the Jurassic is home to some of the most well-known and best-loved dinosaurs that ever walked the earth. Now, I'm going to be honest, there's a good chance that you know more about these spectacular creatures than I do. But just in case someone has managed to come this far without picking up dinosaur basics, here are a few essentials. There are the enormous long-necked sauropods, including such familiar faces as Diplodocus, Brachiosaurus and Apatosaurus. There are the plated stegosaurs, which you should treat with as much respect and fear as an angry rhinoceros. Then there are the carnivorous theropods, which range from the turkey-sized Chirostenotes to the 12-metre monster Allosaurus. More alternative holidaymakers might try to seek out some lesser-known dinosaurs, such as the tiny two-legged Chaoyangsaurus. This cat-sized dinosaur is, believe it or not, the earliest ceratopsian, the group of dinosaurs that would eventually give rise to Triceratops. Look out for the small bony plate and ridges on its head. These will one day evolve into the enormous bony frill of Triceratops and its relatives. The Jurassic is also home to the unfairly named Gargoylosaurus, one of the very earliest ankylosaurs, and by no means an ugly creature. Another group of dinosaurs that you might encounter are a little more familiar: birds. Elsa, I think it's fairly common knowledge now among backpackers that birds evolved from small, bipedal, carnivorous dinosaurs. But do we know how exactly they evolved? Did they start gliding, or flapping, or running and jumping? Or do we simply not know?
I don't think that we know it in the sense that we can't be ever 100% sure exactly how it happened. I also think that there's still a lot of debate about why they took to the air. Basically, was it ground up or trees down? By which I mean, were they starting from the ground and flapping to get up at something? Or were they in the trees and they kind of were gliding from tree to tree or maybe down to the ground, perhaps to escape predators or something? I don't know if I can think of any evidence that would ever actually nail it one way or the other. I think this is always going to be an open question. But I have my own personal theory. So the Jurassic is pretty cool as well for insects. You get the first beetles at this time and the first butterflies. So I have a theory that is what drove them to start flapping around the place. I think they were going after all those beetles because we have tons of them as well in the fossil record from this time. You get lots and lots of their elytra, their little beetle cases on their backs. So that's my theory. I think they were beetle crazy and they were going for those beetles.
Oh, very interesting. Now, when I see these early birds, particularly towards the end of the Jurassic, to me they look fairly similar to modern day birds here in the Holocene. Are there any differences between these early Jurassic birds and modern day birds, or are they pretty much the same?
I think if you saw one at first glance, you could just think it was some kind of slightly weird leggy bird. But when you have a good look, there clearly are some differences. I mean, at this point, they still have these little clawed hands. They have killing feet, as they call them, it's the sort of Jurassic Park-like velociraptor killing claw on the back feet. So they still have that, which of course birds don't have now. They also had tails. They had these long bony tails, which had feathers on them. But I mean, I think they would have been much more substantial and quite noticeable. Oh, and of course teeth. They have mouths full of teeth. So when you would take a second look, it would be pretty clear that these were not birds. Or not as we know them, I should say.
Nothing I'd recognise today then, which frankly sounds like a good thing now that I'm hearing about these teeth and killing claws.
But bear in mind they're all quite small. So, unless you came across a whole flock of them all going for you at once, you'd probably be all right.
Another major first for this point in prehistory is the appearance of the first true mammals. And I would love to see some of these animals on my trip in the Jurassic. So I guess first things first, what am I looking for? What do these very first mammals look like?
Well, mammals did a really clever thing in the Mesozoic as a whole. So before that, in fact, even further back in time, the mammal line had included really big animals, the biggest herbivores and the biggest carnivores. They were all among this wider mammal line called the synapsids. But in the Mesozoic, in the time of dinosaurs, reptiles had taken those niches, those large-bodied niches. So mammals did a really smart thing because they basically went the other direction. They thought, right, you guys are great at being really big. Let us show you how it's done when it comes to being really small. So they became extremely small, the sort of size of things like shrews and mice today. Tiny little things would easily curl up and fall asleep in the palm of your hand. So that's what you would basically be looking for, very, very small mammals. And you'd probably find it difficult to find them for the same way that, if you go for a walk in the woods today, you don't just see mice everywhere, even though actually there are mice everywhere.
Yeah.
They're in amongst the foliage and they're burrowing under things. Apparently we're always, what's that statistic? We're always like 10 feet away from a rat, but you don't see them. So I reckon in the Jurassic on your backpacking trip, you would perhaps maybe at night when you set up camp, you would hear some rustling and look over and maybe see one of these little mammals. They would have been, as I say, quite small, the biggest, probably not bigger than a guinea pig. And they certainly would have had fur. They would have looked recognisably like a little mammal.
Okay, wow. So you mentioned you probably hear them at night, and that's interesting because when I think of a lot of mammals today, like mice or badgers or foxes, a lot of them are nocturnal. So was that the case for the Mesozoic mammals as well? Would I have to head out at night if I wanted to try and hear them or see them?
So we think so. Now, okay, maybe some of them did also do things during the day, because there's always some variation. But when we look at mammals alive today, most mammals now are nocturnal. And most mammals are actually colourblind as well. Primates are one of the rare exceptions. We've re-evolved having colour vision. But most mammals are colourblind. They don't see particular parts of the spectrum. And it's because the common ancestor of all living mammals was likely nocturnal. And if you're around at night, you don't really need to see colour because basically everything's black and white, So they lost through lack of use, they lost some of the structures in their eyes and some of the genes that allowed them to see colour vision. So probably we are looking for things at night more than during the day.
You mentioned the synapsids, this broader group that mammals belong to. But what exactly did mammals evolve from? What was the ancestor of these very first mammals, and therefore every other mammal?
This is a really cool thing because I think a lot of people still have this idea that mammals come from a branch of reptiles. But we now know that that's not the case. Actually, the ancestors of reptiles and the ancestors of mammals, they fundamentally split right back at the beginning from the first animals that came on land over sort of 350 million years ago, so way before the time of dinosaurs. So this group you talk about there, Synapsida, they've been doing their own thing for a very, very long time. And of course they split off into lots of different types of creature, lots of different animals. Some of the first big giant herbivores, some of the first big carnivores with saber teeth and things like that. But of course they've come and they've gone and different branches have made it through, and it was the ones that ultimately include ourselves, the mammals, that made it through the Mesozoic as well. For various reasons, things like climate changes and mass extinctions have just sort of reset who's big and who's doing different things at different points in time.
On a previous trip, I visited the Triassic, and I managed to catch a glimpse of some of these mammalian ancestors. And to my admittedly untrained eyes, not a lot seems to separate these non-mammalian synapsids from the very earliest true mammals. So what distinguishes these two groups? I mean, what makes a mammal a mammal?
I think you're absolutely right. I think if you were hiking through the Triassic, or if you were to hike through the Jurassic, you wouldn't be able to tell much difference from the outside. The thing that we look for as paleontologists is actually in their jaw bones. So when you're studying mammals, it's all about the teeth, and it's all about how they bit and how they chewed things. And so the mark that we've basically placed in the fossil record is between whether they have a jaw joint between their dentary and squamosal bones or their articular and quadrate bones. So it's a very technical kind of thing, but it basically just signals that they're starting to chew differently and rearrange their jaws. And the parts that they stop using in the back of their jaw, the parts that used to be involved in that jaw joint, eventually actually become incorporated into their ears and give them super hearing in later mammal groups. So this is all very sort of fundamental, important stuff for mammals.
Oh, okay. Now, when I think about mammals today and some of the, I suppose, least derived mammals, the monotremes, which, among other exciting things, they lay eggs. Now, do we know how the earliest true mammals in the Mesozoic reproduced and reared their young? Were they laying eggs? Did they have a pouch like marsupials? Or is it something we don't yet know?
Oh, I'm so glad you said least derived and not primitive. It's one of my bugbears. So, yeah, I mean, today we have three main groups of mammals, don't we? We've got our platypuses and echidnas, as you say, laying eggs. We've got placental mammals like ourselves. And then we've got marsupial mammals like koalas and wallabies and so on. So you've basically got egg layers, and then the other two groups are live birth. We actually, the short answer is, have absolutely no idea when the live birth mammals, when that happened. It's a really hard thing to pin down because it's all about soft tissues, and of course they don't preserve. First of all, we've never found a fossil mammal egg, but we've also never found any baby mammals from the time of dinosaurs. The closest thing is some predecessors just before proper mammals. We've got some of their youngsters, but we've got no actual baby proper mammals. Not just that, but you'd have to find them inside a mother. You know, you'd have to find a mammal fossil with either eggs or embryos inside it. And that's just going to be so difficult and so specific. Yeah, I think it's going to be a really difficult thing to answer. In terms of their genes, though, again, it gives us a bit of a constraint, but not a particularly good answer either. We're looking at around about the 160 million year mark, but it could be as far back as 200 million years ago or as recently as sort of 100. So that's a massive period of time. But at some point in there, at least a couple of groups switched or began to basically retain their young for longer and eventually gave birth to live young.
So it's one of those great unknown frontiers in paleontology then.
Oh, it really is. It's, I think, one of the last really big fundamental questions.
Now, you mentioned a minute ago that by the time of the Cretaceous, the later Mesozoic, you've got slightly larger mammals. And that's interesting because the standard narrative of Mesozoic mammals, the one that I was familiar with, is that they spent the entire Mesozoic as small, scared little shrew-like things. And that was only after the dinosaurs died out that they started to diversify and to get bigger. Is that still the case, or do we think, or do we know, that they were diversifying during the Mesozoic?
That was definitely the picture of mammal evolution, but it is completely wrong. That is not true at all anymore. And really, we've got fossils coming out of China to thank for changing our view of this. So up until, really, almost until the turn of the millennium, we virtually had no complete Mesozoic mammal fossils, like as in their whole skeletons. We've really mostly had just individual teeth and a few jaws. And the old cliche was that you could pretty much fit all of the mammals from the time of dinosaurs into a shoebox because it was just so few fossils. And that was actually pretty much it was almost true. Now that is certainly not the case. So in the last 20 to 30 years, we've been finding these beautiful complete skeletons, particularly from China. And of course, if you have a whole skeleton, you can start to tell not just what it ate, which you can tell from its teeth, or what it was related to, which actually in mammals, you can also tell from its teeth, but you can see how it moved in its environment. So we've begun to find things like specialist aquatic mammals that were kind of like otters, little otters. We've found specialist diggers. We've got a Jurassic mole called Docophosser, which is one of my absolute favourites. It's got these little shovel paws. And the fossil's great because it looks kind of like Nosferatu, like a vampire kind of stalking across the stone. Got specialist climbers. We've even got flying squirrel kind of mammals. So with these, what are called patagium, it's like a flap of skin that connects their ankles with their wrists. and they were able to glide from tree to tree. So, I mean, we've really got, I would say, almost everything that a small mammal can do today, they could do in the Jurassic and in the Cretaceous. So that extends our whole understanding of how they evolved and how diverse they were ecologically, right back to the very, very beginning of mammals.
So, if there was an opportunity, they were taking advantage of it.
Absolutely. What's that phrase about, like, there's nothing new under the sun? And I think the more you look at fossils, the more you realise everything's been done before. But, also, it's worth saying that a lot of these really cool innovations that mammals were doing in the time of dinosaurs, it was happening in the groups that we are not related to. So the placental and marsupial mammals belong to a group called Therians. And they did have their sort of earliest days in the late Jurassic, early Cretaceous. But actually, they were all boring. They were the cliché shrew, mice kind of boring things, maybe tree dwelling, but apart from that, they didn't do anything much. It was actually the earlier, also modern mammals, but the groups that have not then continued after, they were the ones doing the exciting things.
Well, the rain's showing no sign of easing off, so I'm thinking I might head home and try the Jurassic another day. But before I pack up, there's just time to ask both of my guests for their one top recommendation for the Jurassic.
I think if I could do anything, I would pack my backpack into a sea kayak, and I would go sea kayaking among the little islands that are now Scotland. But in the Jurassic, a lot of them would have been islands as well, and would have been low-lying. And I'd probably, I'd take my binoculars as well, definitely, and my camera, my notebook, and I would check out all the lagoons and the marginal environments. There's plenty of food there, so I could last for weeks. I could just take things off the shore. We've got seaweed, we've got marine life. Yeah, and I'd camp out on the little islets so that I was safe from the dinosaurs. And I'd probably study all these little mammals. And we've also got like the first squamates, like lizards and snakes and stuff. I'd be looking for those, and I would just have a fantastic few months, I think, sea kayaking from island to island.
And how about you, Evelyn?
Well, it's a different question because I would have so many things that I would love to do in the Jurassic. But I think that one of the highlights would be something like a horse ride on a Europosaur. Not just because I like to go on horses, but also because I could go with them and see how they go there and eat the plants and how they do it to chop them down. And I would really love to see them during one of their dinners, so get a nice ride with them and have a nice dinner together in the evening, because you don't fear to be eaten by them in any case. And it would quite be nice to eat some plants together and see how that works.
Sounds like a great trip.
One of the many that you could do there, but yes, it would be a great trip.
I'd like to thank my two guests, Dr. Evelyn Costaccia and Dr. Elsa Panciaroli, for sharing their Jurassic travel tips. If you've enjoyed what we've been talking about today, then do check out their research. There are links in the episode notes. A big thank you also goes to you for listening. I hope you've enjoyed this episode, and indeed the entire second season. And if you have, please feel free to like, subscribe, share, and leave a positive review. Now that we've explored the entire Phanerozoic, if only briefly, I'd like to say a final thank you to everyone who has appeared on this podcast over the past year. Academics are some of the most overworked people you're likely to meet, and yet every single person I contacted was generous with their time and knowledge, even if it meant giving up their weekends or evenings, and all without ever asking for anything in return. It's a testament to their passion for science and prehistory, and I hope that I've been able to convey at least some of that in these episodes. So, until next time, safe travels.
Warning, time engines critical. Warning, time engines critical. Warning, time engines critical.